Examples of acids and alkalis are commonly found in everyday life. Most acids have the following characteristics. They have a sour taste. They turn blue litmus solution or litmus paper red. They react with some metals to release hydrogen. They react with marble and other materials made of calcium carbonate to release carbon dioxide. On the other hand, alkalis have the following characteristics. They have a bitter taste. They have a wet and slimy feeling. They turn red litmus solution or litmus paper blue. Apart from these characteristics, acids and alkalis are capable of cancelling out each other's effects. Sodium hydroxide is a strong alkali. When several drops of litmus solution are added into it, it turns blue and shows a pH value of 11. Now slowly add some hydrochloric acid into it. The pH value keeps lowering, indicating that its alkalinity is decreasing. If we continue to add acid into it, the solution will suddenly turn red. The pH value is around 2 to 3, showing that the alkaline solution has become acidic. The acid added into the sodium hydroxide solution has cancelled out the solution's alkaline property. Let's try it the other way round. This is a cup of hydrochloric acid. Add some drops of litmus solution into it and it turns red. The pH value is around 2. Now slowly add some strong alkaline sodium hydroxide solution. The pH value keeps rising, showing that the acidity of the acid is decreasing. If we continue adding sodium hydroxide, the liquid will suddenly turn blue. The pH value is around 11, showing that the acidic liquid has changed to alkaline. The added alkali has cancelled out the acidity of the hydrochloric acid. Both experiments show that acid and alkali are capable of cancelling out each other's effects. What has happened when the two substances were mixed together? Let's try this experiment. Mix sodium hydroxide solution with hydrochloric acid. Place the mixture on an evaporating dish and heat it. When the solution has evaporated completely, some white solid matter is left on the dish. This solid is sodium chloride or table salt. Hence, an acid reacts with an alkali to produce a salt and water. In this experiment, hydrochloric acid reacts with sodium hydroxide to produce sodium chloride and water. This process is called neutralization.
The following experiment illustrates how neutralization takes place. This flask contains hydrochloric acid and the other contains sodium hydroxide. Both solutions have the same concentration. Drops of universal indicator are added into each. Hydrochloric acid turns red. With a pH value of 2, showing it is acidic. Sodium hydroxide solution turns purple. With a pH value of 12, showing it is alkaline. Now take equal amounts of acid and alkali and mix. This equipment can control precisely the flow and can thus accurately mix the same amount of acid and alkali together. The mixture shows a light green colour, characteristic of a pH 7, indicating it is neutral. In other words, hydrochloric acid reacts with sodium hydroxide to give a neutral solution.
We can repeat the experiment by means of a simple method. Here are 2 bottles of acid and alkali of the same concentration, each with the universal indicator added in. Take the same amount from both and mix them together. We can see that the mixture turns green slowly, indicating that the acid has neutralized the alkali to form a neutral solution with a pH value of 7.
Plants need soils of a specific pH for healthy growth. In general, a slightly acidic soil with a pH value around 6 is best for growing vegetables. However, soil at very low pH value is too acidic for vegetables.
To measure the pH of soil, we need to boil some water first, so as to eliminate the dissolved acidic carbon dioxide which might affect the result. Wait for the water to cool down. Place a strip of pH paper on the bottom of a transparent container and cover it with a piece of filter paper. Put the soil in. Pour the boiled water into the soil until the soil is soaked through. Wait a couple of minutes for the water to reach the bottom of the soil mass and come into contact with the pH paper. Turn the container upside down for a better view of the color of the pH paper. Check it against the color chart and we can get the pH value of the soil sample.
If the pH value of the soil is too low, that is, too acidic, what would a farmer do? When the soil is too acidic, a farmer would put slaked lime into it. Slaked lime dissolves in water and produces an alkaline solution. It can neutralize the excess acidity in the soil, which then becomes suitable for crops again. A stomachache may result from various factors. The most frequent cause is the excessive secretion of gastric acid. What is gastric acid? What is its function? Why will an excess of it cause stomach pain? How do we relieve the pain caused by gastric acid?
Excessive secretion of gastric acid makes the gastric juice too acidic. Inside the stomach, there is a secretion composed mainly of hydrochloric acid. As it is formed in the stomach, it is also called gastric acid. On average, the stomach can produce about 2 liters of gastric acid daily. The major function of stomach is to digest protein. To activate the enzyme involved in protein digestion requires a highly acidic environment at pH ranging from 1.5 to 2.5. As gastric acid is in fact hydrochloric acid, it can provide a strong acidic medium that is needed for the enzyme in stomach to break down proteins. But have you ever thought about this? The stomach, like food or other organs in our body, is also made up of proteins. The enzyme inside gastric juice cannot differentiate the food proteins from those of the stomach wall. Is it possible for gastric acid to digest the stomach itself? In fact, the structure of our body is a work of wonder. In between the stomach lining and the gastric acid, there is a layer of mucus separating the two, hence preventing the gastric acid from digesting the stomach wall. However, due to a group of factors, the balance in the stomach may be upset when too much gastric acid is produced. The activity of the Helicobacter pylori bacteria in stomach also weakens the mucus layer. Hence, gastric acid can penetrate the mucus layer and destroy the cells of the stomach lining. This leads to stomachache and may result in a stomach ulcer. We use antibiotics to kill the bacteria. To relieve the discomfort caused by excess gastric acid, we need to take medicines containing antacids to neutralize the acid. Different types of stomach medicines contain different compositions of antacids. However, all of them are alkaline chemicals, such as magnesium hydroxide, aluminium hydroxide, etc. These alkaline substances can neutralize the excess acid in the stomach and restore the normal level of gastric juice.
We can use an experiment to demonstrate this process. First of all, grind up some stomach medicine containing antacids. Add water to the powder. Stir it to speed up the dissolving of the powder in the water. Add the stomach medicine solution gradually into a cup of hydrochloric acid, which represents gastric acid. Observe the change in its pH value. Clearly, the pH value rises slowly, showing that the acidity of the acid is decreasing. This shows that some of the acid has been neutralized by the antacid in the stomach medicine.
Mosquitoes are very annoying because they may bite us and cause the wound to swell up and become itchy.
When a mosquito lands on the skin, It uses its fine, long needle to pierce into the skin to suck blood. Saliva containing formic acid is discharged through the sting. The saliva causes dilation of the blood vessel and prevents blood coagulation. This helps the mosquito suck blood. Formic acid is the cause of the swelling of the wound and the itchy feeling of skin. To relieve the swollen and itchy wound, we normally apply some medicated ointment onto it. There are a variety of chemicals in the medicated ointments, and the mechanism is quite complicated.
Apart from using medicated ointment, some people may apply diluted sodium hydrogen carbonate solution or aqueous ammonia onto the wound. Add drops of the solutions onto the red litmus paper. The paper will turn blue, showing that the solutions are alkaline. Both sodium hydrogen carbonate and aqueous ammonia are weak alkalis. They can neutralize the acidic secretion in the mosquito bites without harm to the skin. Having been neutralized, the blood vessels in the wound will stop dilation and the itchy feeling is relieved.
However, we should not use these alkaline medicines to treat stings by wasps.
The reason is that the secretion in the wasp's sting is basically alkaline. Therefore, people used to apply vinegar onto the wound for relief. Vinegar contains acetic acid, which is a kind of weak acid. It can neutralize the wasp's secretion without hurting the skin.
We should not use the medicated ointment randomly for relief of insect stings. When insects bite or sting, they may simultaneously inject poisons into our skin, which might lead to serious consequences, such as dizziness, fainting, pain, or even fever. In such cases, the victim should consult the doctor for treatment immediately.
Acids and alkalis are used in many industrial manufacturing procedures. Sulfuric acid is used to clean the surface of steel plates before they are plated with colouring substances. If the acidified wastewater is discharged into rivers and the sea, it will lead to water pollution. Therefore, industrial wastewater must be treated with lime to neutralize any excess acids to avoid possible contamination of the environment. On the other hand, wastewater discharged from dyeing factories is usually alkaline, with pH value ranging from 10 to 12. The discharge of alkaline wastewater will likewise threaten survival of aquatic organisms. Therefore, sulfuric acid is added to neutralize the excess alkali before the wastewater is discharged. As a matter of fact, there is no need for the industrial wastewater to be discharged at the neutral pH value of 7. According to Hong Kong laws, the acceptable pH level for discharge of industrial wastewater ranges from 6 to 10. At this level, the possible damage of industrial wastewater to the environment is considered acceptable.